LearnCity. My name is Praise, and in today's class we'll be discussing on tangents to a circle. A tangent is a line that touches a circle but does not cut the circle. Now, it is important to remember the following: that a tangent to a circle is perpendicular to the radius drawn to its point of contact. Now, it is perpendicular to a tangent at its point of contact where it passes through the center of the circle. What am I trying to say? We have a circle. Then we have this line. From the center of the circle, now here we have this. A tangent to a circle is perpendicular to the radius drawn to its point of contact, which means this point here is perpendicular to the line drawn, and the point of contact passing through the line of the circle, passing through the center of that circle, is perpendicular to the tangent. Now, when we have something like this, it is important to know that MTN is perpendicular to OT, representing it as O. It is perpendicular to OT. So which means this line here is perpendicular to this line. Now, to solve some examples, TA is a tangent at A to a circle, circle O. AB is a chord. Now, if BAT shows x degrees, show that BOA is 2x degrees. Here is saying that TA is a tangent to A. Now, AB is a chord. We have AB as a chord. Then we have BAT as x degrees. So we need to show that BOA is 2x degrees. Now, we need to draw a circle where we have this, say that tangent to A. We draw a line where we have O and we have A. Now we have AB as a chord. We have AB as a chord where we have BAT as x degrees. We have BAT as x degrees. So our AB, which is our chord, we have our chord here. So we have BAT, which is our x degrees. So we can just bring it like this. Yeah. So joining this together, we can have this to be our x degrees. Now, we should know that here is 90 degrees. Now, we should know that said BAT is x degrees. So we can represent this as T, A, and B. Now, where we have BAO to be 90 degrees, which is here. So we have BAO is 90 degrees. Now, we now have it to be 90 minus x, as that the radius is perpendicular to the tangent. So we have it to be 90 minus x. Now, for the total sum of angles in a triangle, which is 180 degrees, and we know that our x is 90 minus x, then we have it to be BOA will now be 180 degrees minus 2x. So we have it to be 180 degrees minus 2 into bracket 90 plus x. So now we have it to be 180 degrees will now be minus 2 times, that's 180 degrees, plus times minus 2x. Sorry, this is minus. So we have plus 2x. So 180 minus 180, this cancel each other. So we have it to be 2x, which proves that our tangent, which is BAT to be x naught, then our POA is now 2x degrees. Now moving to another example, we have from the diagram below, PRT is a tangent whose contact point is P to the radius OP of the circle. If POQ is 106 degrees and QRT is 90 degrees, find QRP and PQR. We have this circle here and the tangent. Now this is P and T. We have O. Now contact to OP of a circle from point Q where we have PRT. So we have this to be R. Now we already have this diagram, so we have to look for QRP and PQR. Now to find QRP, now we first look for our OPQ. We have OP and Q. Our OPQ will now be 180 minus 106. 180 minus 106 is 74. Then dividing it by 2 as the base angle of the isosceles triangle will now be 37 degrees. Now we have our QPT to be 90 degrees. We have it to be 90, okay, our OPT to be 90 degrees. We have our OPT to be 90 degrees, which is the radius to the tangent. Now to find our QPR, we then have it to be 90 minus that 37 degrees. So we have 90 minus 37 degrees. So we have it to be 53 degrees. So it will now be our OPT minus our OPQ. It will be OPT minus our OPQ. Using it to get our 53 degrees. Now to find our PQR, we have it to now be 180 degrees, which is the total sum of angles in the triangle, minus our QP minus our QPR. So we have this to be 180 degrees minus our 53 degrees plus we have 37 degrees. So we have this to be 180 degrees minus 90 degrees. We have it to be 90 degrees, which is the sum of angles of the triangle for QPR. This is the sum of angles in a straight line. So for our PQR, it will now be our 180 degrees minus 53 plus our 90 degrees. That will be 180 degrees minus 53 plus 90. So we have it to be 180 degrees minus 143 degrees. So we have it to be 37 degrees. So we have it to be 37 degrees. And this brings us to the end of our class of tangent to a circle. Do subscribe to our YouTube channel, like and comment, and I'll be seeing you in the next class. Thank you.